Welcome back. Good morning and good morning. Welcome back and good morning. All right, this morning we are going to be discussing lesson 1.1 symbols and expressions. I would encourage you to take notes. Symbols, we will be doing some writing, and writing is good for you. Symbols and expressions. This is Algebra 1. Okay, so let's start with something we know. So we may not know that the numbers have different sets and they have different titles, but let's start with natural numbers. These are your counting numbers. So that is 1, 2, 3, 4, so on and so forth. With respect to algebra, that is a set of numbers. That's the set of numbers called natural numbers. And this may come in handy a little later. Maybe not today, but I'm introducing some things that are really, really necessary and foundational for Algebra 1. So the next set of numbers that we refer to and we use a lot are whole numbers. And this is important because when we discuss whole numbers, we need to make sure that we understand the difference between a whole and a natural, because a whole number is all the natural numbers and the number 0. So this is your natural numbers and 0. So that is 0, 1, 2, 3, 4, so on, going upwards. That does not include negative values. So at this point, our natural numbers are just our counting numbers starting with 1. Our whole numbers are the counting numbers and 0. Now, what is new, and it may have been introduced before Algebra 1, but we're going to review it just to make sure that we're all on the same page, is variable. I know before now maybe blank spaces and maybe even variables, but that's okay. We're going to define it again. So a variable is a letter that represents one or more numbers. One or more numbers. And for example, we like to use X and Y a lot, and then M and N, but any letter of the alphabet can be a variable, and we will use those interchangeably, and we just need to understand that that's something that we will see all the time. The next vocabulary word that's really important, just as far as you understanding the concept, what it means, is algebraic expression. Algebraic expression. So this is an expression that contains at least one variable. An expression, S-S-I-O-N, that contains at least one variable, and we know that to be a letter. So I'm going to give us a couple of examples here. For example, that was a slip. I meant to just write example, but that's okay. For example, we're going to say 124 divided by y. That is 1. X plus 6. That is a number. 4x. That is an expression. It is an expression. It has a letter, a variable. It has an operation. That is an expression. Now let's talk about how you actually evaluate expressions. So you evaluate an expression by substituting a number for each variable and calculate it. So let's talk about evaluation. E-V-A-L-U, how you evaluate an expression. And then we'll talk about substitution. So this is the process by which we substitute a number for each variable. And calculate. To evaluate, there's a two-step process. First, you substitute. So let's look at substitution, and then we will look at examples. So the process of substitution, and I connect this to like when you have a substitute teacher, for example. Your teacher's not at school, the substitute is there in place of that, and that's kind of what we need to think about when it comes to substitution. We're going to replace our variable with a number. So we are replacing the variable or variables with a number. And we are going to do a couple examples to show both. So let's look at some evaluation just as examples. So evaluate. And let this be example number 1. So we are going to do, let's see, we'll number later, but all the directions at this point for these problems will be to evaluate. So let's look at the first example. Let's look at m plus 8 for m equals 9. So evaluate that expression, as that is an expression as we defined before. So we're going to write our expression again. That's just me. So m plus 8 equals, now I'm going to substitute because I want to know what this value equals if I substitute in the value, meaning I'm going to take the m out. It's gone away. I'm going to replace it with the value that is, or what it represents. So the m represents a 9. So I'm taking the m out. I'm leaving the plus 8 because I know what that is. Now I'm going to actually calculate. So 9 plus 8 is 17. So in this particular problem, if we were to evaluate m plus 8 for m equals 9, then we're going to find that our expression is equivalent to 17. So m plus 8 equals 17 for us. Next example. And again, the directions are still going to be to evaluate. I believe there are going to be 6 problems. So I'm going to put the previous one back because I'm going to put these the directions for number 1 through something. We'll see once I get finished. I do a lot sometimes. So these are the directions for all of these to evaluate. So let's look now at example number 2. Example 2, and we are still evaluating. We are still evaluating. So in example number 2, we're going to evaluate 5n for n equals 4. 5n for n equals 4. So first, just to make sure that we're all on the same page, the operation between the variable and the constant, and that is a constant, you know, and I probably should have defined that earlier, but that's okay. We'll move forward for the moment, is multiplication. So I'm going to write it just to make sure that we understand that when we do not see an operation, physically see an operation between the variable and a number, then that's representative of multiplication when it looks like this. So that is 5 times n. So 5n, and now we're going to substitute that value. We know that we want to evaluate for n equals 4, so then 5 times n changes to 5 times 4. You can use that, or you can use parentheses. We like parentheses. Parentheses can also represent, and do also represent, multiplication. At this point, we calculate, and 5 times 4 is 20. So for 5n, evaluating that for n equals 4, then we have found that for our answer, 20 is what is evaluated after that point. So let's move to another example. Example 3. Hopefully I'm not moving too fast, but this is a video, so you can stop it and rewind it as needed to make sure that I'm not moving too fast for you. Let's look at another problem. So we have done addition, we've done multiplication. Let's do some subtraction. So let's evaluate x minus 7 for x equals 20. Why not? That's right there. All right, so we see that we're going to do subtraction, and we just simply need to substitute in the value that we have. We were informed that x equals 20. So x minus 7. And again, you don't have to write this step. I'm writing this step because I'm teaching in this moment. But if you can if you can jump directly from x minus 7 to 20 minus 7 because you're there, then do that. And then calculate, and that equals 13. 20. Yes. So for example, number 3, you should have got 13. So if you're working with me, if you're working ahead of me, then your answer should be 13. Example number 4. Let's look at example number 4. So I'm going to make this one a little bit more complicated because I just want to make sure that we understand that it is possible to have more than one variable. So let's look at a plus b. Yes, I know, 2 variables. For a equals 10 and b equals Again, I'm going to start by rewriting the problem. So a plus b is what I want to substitute. My a is equal to 10, so I take the a out and I replace it with the 10. My b, I leave my operation, which is addition. My b is equal to 12, so I remove the b and replace it with the 12. At this point, I have all the information I need, and I can begin to calculate it. So 10 plus 12 is 22. So the example, or the answer to example number 4 is 22, based upon the information that we input for the problem. The final example, I think, is example number 5. I wanted to show you a little bit of everything, and I think we might have gotten there at this point. Let's look at another problem. Did I do division? Oh, I haven't done division, so no, we'll have 6 examples. Let's do division here. So let's see about 18 divided by y. Let's evaluate that for y equals 6. Just to make sure we're all on the same page, this is the same thing as 18 divided by y, even though we write it with the line 18 divided by y. So the operation we're working with right now is division. At this point, we know what our y is equal to, so we're going to take the y out and substitute it with the value that it is equivalent to, which is 6. So 18 divided by 6 is equal to, and now we actually calculated, that's 3. So when we're looking at example number 5, we're using division and we calculate, we find that 18 divided by y for y equals 6 is equal to 3. And let's do one more example. And I think I have enough space on this particular piece of paper before I conclude this video. Let's look at example number 6, which means we go back here to the beginning, and not the beginning, but the first page. And yes, that should be evaluate for number 1 through 6. I know you're gonna be like, you are so random, lady. I am. Just wait till I actually get in the classroom. Monday. Anyway, so final example, we're going to look at another problem. This one is going to be multiplication, but we're substituting in 2 variables. So let's look at m times n, and I'm not going to put the symbol because we know that, and we're going to assume that we know that that is multiplication at this point. And really, I'm not assuming, we've already defined that. So m times n for m equals 6 and n equals 4. And I wrote the wrong letter. This is why I have whiteout tape. It's my friend. N equals, what did I say, 4? I hope so, because that's what I'm doing in this problem. So I'm going to rewrite the problem. M times n is equal to, my m is 6. So I take the m out, replace it with a 6. My n is 4. I remove the 4. I replace it or substitute it with a 4. And now I calculate. So 6 times 4 is 24. Hopefully I didn't move too fast. I thank you so much for your time. And more to come. So please subscribe. Please share if you know anyone who needs help with Algebra 1. There are so many more lessons to be taught. This is the first section of lesson 1. So please look for the next video, which will be 1.1 part 2 or something to that nature. Thank you so much for your time, and I hope you learned something today, and I hope that it is helpful. Have a good one.